As we've been discovering patterns of multiplying with decimals, we've filled in some parts of a chart for 2 different days. This was our first day. Then on the second day, instead of 5 whole things, we multiplied 5/10 in our pattern. Our third day here, we are going to not multiply 5 whole things. We are not going to multiply 5/10. We are going to multiply 5/100. So in this page, it'll be 5/100 times powers of 10, which means we should have 5s and 0s in every answer. Do you think these answers will be larger or smaller than these answers? If we are only taking 5/100 of these numbers, will our answers turn out to be larger or smaller than when we took 5 whole amounts of these numbers? Well, when we just took 5/10 of those same numbers, the answers got smaller by a place. So they got 10 times smaller when we multiplied by a number that was 10 times smaller. Now we're multiplying by a number that's 100 times smaller than 5. It's only 10 times smaller than 5/10. So these numbers should be 1 place smaller than when we multiplied times 5/10. These answers should be 2 places smaller than when we multiplied by 5 whole things. If you didn't follow that, that's okay. We'll still see that this makes sense with counting the number of decimals and placing it. So let's do this very first one. The number with the most digits goes on top if we're multiplying. We do not line up the decimals if we're multiplying. 5/100 one time. Well, 1 times 5 is 5. 1 times 0 is 0. How many places past decimals? Well, there's nothing here. We have 2 digits to the right of a decimal here, so we must make our answer smaller by 2 places, 2 moves of the decimal. And duh, anything times 1 is that amount. So you can double check yourself that way. Fine. What if we take those 5 pennies 10 times? Oh, well, 5 pennies 10 times is going to give us 50 cents, isn't it? What if we take those 5 pennies 100 times? Well, 100 pennies is $1. So we have 100 pennies 5 times. That should give us $5. Now, I could write it this way too. 5 pennies 1,000 times. Oh, wait a minute. 5 pennies 1,000 times. That'd be $50, wouldn't it? Interesting. See any patterns? What if we take 5 pennies, but we don't even take a whole penny? We take 1/10 of those pennies. Oh, gracious. Set it up down here. Most digits on top. Do not line up decimals to multiply. 5 times 1 is 5. 1 times 0 is 0. How many places do we need to doink the decimal? Once, twice, thrice. Make this smaller by 1 place, 2 places, 3 places. Fill in the decimal. What about 5/100ths? Oopsies. I wrote 10/100ths, which I did not mean. I want 1/100th of those 5/100ths. So I've already only got 5 pennies, and I want to take those 5 pennies and split them into 100 pieces. Wow, this is going to be really small. How small? 1, 2, 3, 4. We know we're going to have to move the decimal 1, 2, 3, 4 times. The 5 will go right here, and all the rest of these will fill in zeros. What about if we have 5/100ths? 1/1000th of a time. Hopefully you see this answer should get, there went the lights, even smaller. How much smaller? 1, 2, 3, 4, 5 places to move the decimal. 1, 2, 3, 4, 5. Decimal ends up here. 1 times 5 goes in the smallest place. Everything else fills up with zeros. Wowza. Kind of a small amount, isn't it? What will happen when we go over here and we do 5/100ths times 7? Now I'm going to show you something. 5/100ths times 7. I know I'm going to need 2 digits after the decimal. I know 5 times 7 is 35. It tells me where to put my decimal. 5/100ths times 70. I am going to need okay, wait a minute, I did something wrong here. Didn't I? Nope, not yet. Ha! There's where, nope, that's not wrong. I am going to, I thought about stopping the recording, but no, it's good for you to see that sometimes when I'm trying to show you patterns, I get confused in the patterns myself. So I think it's going to be best for us just to go ahead and do this and then look for the patterns. How about we do that, huh? So, 7 times 5, there is going to be that 35 involved. We need this 0 for 350, and then we need to see what I just did? I did the double-digit multiplication, and I'm going to double-check myself by doinking the decimal twice now, just to prove to myself that, yes, that is what it should come up with. 3 and 50/100ths, or 3 and 5/10ths. 5/100ths times 700 will be 10 times larger. Why? Well, because the decimal had to move through more zeros. That's one way of thinking about it. 5/100ths times 7,000 is going to end up being 10 times larger, 350. There's that 0 on the end. What if I take 5/100ths times 7/10ths? Okay, 0.05, most digits on top, times 0.7. 7 times 5 is 5, carry the 3. 7 times 0 plus 3 is 3. 1, 2, 3 places to move the decimal. 1, 2, there's the third place. Equal sign. 35 thousandths. One place smaller than it was when I multiplied by 7 whole things. 5 hundredths times 7 hundredths is going to be 1 decimal place even smaller. Not tenths, not hundredths. 35 10,000ths. What if I take 5 hundredths times 7 thousandths? So I have 5 pennies, and I'm not splitting them into 10 pieces, I'm not splitting them into 100 pieces, I'm splitting them into 1,000 pieces, and then I'm taking 7 of those for each of those 5 pennies. Weeny teeny teeny pieces. This, don't forget the decimal, is 35 tenth, hundredth, thousandth, 10,000, 100,000th. 35 hundred thousandths. Rather a small amount. Make sure that you have these in your folder, and before you stop, again, take a look at patterns looking across, going up from the baseline, going down from the baseline, thinking about, yes, we doink decimals, that's the steps that we've talked about doing when you multiply with decimals. But why? What does that allow us to show? And remember, a multiplication sign, you can substitute the word of.